So today we will be discussing about how to determine the electrical axis of the heart. So in order to determine the electrical axis of the heart, it's very important to know the location of different leads along with their polarity. And if you know that, it's gonna really make the rest of the story really easy. And if you don't know the position of the different leads along with their polarity, then I would definitely recommend that you should not watch this video at this point. First, you should know this location of all the leads along with their polarity before trying to understand the electrical axis of the heart. So that being said, I would just like to summarize a little bit about the different lead system that we use for forming the different waves of the ECG. So there are two different types of planes. The first one is the frontal plane and the second one is the horizontal plane. So as the name suggests, the frontal plane is called the frontal plane because it will be having all the leads that will be detecting the electrical activity of the heart in the frontal plane. Similarly, when you talk about the horizontal plane, this is the plane which will be detecting the electrical axis of the heart horizontally. So the leads that are going to take care of the frontal plane will be the bipolar lymph leads and the augmented unipolar lymph leads. So the bipolar lymph leads are going to be lead 1, 2, 3, which in this image are this one, lead 1, lead 2, lead 3. Similarly, the augmented unipolar leads, they will also try to detect the electrical activity of the heart in the frontal plane, and these are augmented limb leads L, AVL, AVR, AVF. So this stands for left, R stands for right, and F stands for the left leg. So they in the image are depicted by AVL left side, AVR the right side, and AVF the one given here. Now it's also very important to know that when I say the lead 1, I actually point towards this side and not towards this side. Even though this entire line is the axis of lead 1, but why I say that this is the side of the lead 1, because here is where you have the positive polarity. So wherever you will have the positive polarity, that is the point where you will be referring to the exact lead, right? Now after frontal plane, we have the horizontal plane. So the horizontal plane will be having all the precordial leads that range from V1 to V6, and they will be detecting the electrical activity of the heart in the horizontal plane. Now coming to the relevance of these two planes when we determine the electrical axis of the heart, we need to know that it's only the frontal plane which we really need to know thoroughly if you really need to find out the axis of the heart, because these are the leads which will be used for determining the axis, not the precordial leads. So in the entire strip of ECG, the leads that we will be looking for determining the electrical axis of the heart are gonna be lead 1, 2, 3 and AVLR and AVF. So we do not look for anything in the precordial leads as far as the electrical axis of the heart is concerned. The horizontal plane is used for determining the rotation of the heart, not the axis, whereas the frontal plane is used for determining the axis of the heart, right? Rotation is something that I'll be dealing with in some another video, right? Okay, next is what is the normal axis of the heart? So the normal axis of the heart ranges from -30 to +90 degrees. So a point to note here is that this region of the range from -30 to 0 is something that people initially can think of as being abnormal, but this is normal as well. And one reason of it is, or maybe other way to say is, the way you can remember that this is a normal region is that you need to know that the left ventricle is quite thick. It's quite thick as compared to the right ventricle. Hence, the axis of the heart can be normal even towards this side, even towards this side, so it can be normal because of the thickness of the left ventricle. So it's more towards the left side. This is how you can remember. So the normal axis is minus 30 to 90 degrees. So when you talk about infants less than 6 months of age, they might have electrical axis, the normal range of which can be more than 90 degrees, plus 90 degrees, but this is something that we will not be considering right now. We'll just be talking about the adults, that the normal axis is from minus 30 to plus 90. So there are a few concepts that you really need to understand before you try to understand the concept of the electrical axis of the heart. The first thing that you need to know is the position and the polarity of the leads in the frontal plane. This is very, very important. You should know what is the position of lead 1, 2, 3 and AVF, AVL and AVR in order to understand the electrical axis of the heart and all the other concepts. So make sure that before you move forward, you should know everything about them. The second thing you should know about the flow of the current, along with the isoelectric deflection. So you need to see in this given figure that lead 1 and lead AVF are perpendicular to each other. Now the ECG deflection in lead 1 will register the tallest deflection if the current is directed towards the positive electrode. Okay, so you can see that the current is being directed towards the positive electrode. It will register the greatest deflection, that also in the positive direction, because if the current flows towards the positive direction, the deflection is positive. If the current flows away from the positive electrode, the deflection is negative. Again, it will record the deepest deflection if the current is directed 180 degrees or towards the negative electrode. So this is one concept that you need to know, that if the current flows towards the positive electrode, you get positive deflection. If the current flow away from the positive electrode, you will get a negative deflection, right? Now the lead perpendicular to the lead 1 will record an isoelectric deflection. Now what do you mean by isoelectric deflection? An isoelectric deflection is a deflection which has an equal positive and a negative deflection. It does not matter that it's having an initial positive, then negative, or initial negative and then positive. All it means is it should have equal upward and downward strokes. That is an isoelectric deflection. So if you go perpendicular to lead 1 here, that is a lead AVF, you will see an isoelectric deflection, right? So because AVF is perpendicular to the lead 1, right, AVF will record an isoelectric complex. So this is very important concept. So you need to remember that if a current is flowing towards a given electrode or completely 180 degrees from that electrode, it will have the tallest or the deepest deflection, and 90 degrees to it or a perpendicular electrode will have an isoelectric deflection, right? Okay, now we really need to understand the concept of perpendicular leads. So just like I told you before, you really need to know about the location of different leads, right, in order to understand it better. Again, just as a revision, if you talk about lead 1, the lead perpendicular to it is going to be lead AVF. Or the other way around, if you talk about AVF, the lead perpendicular to it is going to be lead 1. You can see here that this is the lead 1 and this is the lead AVF, right? Then when you talk about lead 2, if this is the lead 2, the lead perpendicular to it is going to be lead AVL. Similarly, if we see that in a figure given below, this is the lead 2 and the lead perpendicular to it is going to be lead AVL. Then if you talk about lead 3, which is represented by this gray line here, the lead perpendicular to it is going to be AVR. Similarly, if you see in the figure given below, if we talk about lead 3, the lead perpendicular to it is EVR, given this way. So these are the perpendicular leads. The reason I'm telling you, because we'll be doing some examples, basically we'll be doing 2 examples in which you really need to know about the perpendicular leads concept, right? Okay, so we will be doing this example first and try to find out the electrical axis of the heart. So the first step in finding out the electrical axis of the heart is you have to find a lead which shows you an isoelectric deflection, which in this ECG is actually lead 1, right? So the lead 1, the direction of lead 1 is this way. It is showing us an isoelectric deflection, right? Now the second step is that you have to move to a lead perpendicular to it. So the lead perpendicular to the lead 1 is EVF, right? Now this is the EVF lead given here. Now what do you see? We see a QRS complex here, but it's merely a positive direction, right? So that means that if it's a positive direction, the current might be flowing towards the positive electrode, towards it. So that means the axis is plus 90 degrees, right? So again, the first step is, first you have to look at a lead where you find an isoelectric deflection, right? Then you move to a lead perpendicular to it, that is the lead EVF, and then you look at the perpendicular lead ECG, and the ECG shows a positive deflection. That means that the axis of the heart is plus 90. So what does that actually mean? That means that the major part of the vector is directed towards this side, right? That is why it has the tallest QRS complex. Moving to another example. So let's do it. So what's the first step here? The first step here is to find the lead which has isoelectric deflection. So which in this figure is lead 3. Okay, so we got that. Lead 3, isoelectric deflection. Now if we have to find the electrical axis of the heart, we need to go and find a lead perpendicular to lead 3, which is lead EVR, and this is something that we already know, right? In the lead EVR, we will now observe the deflection, whether it's upwards or downwards. We see that it's downwards. That probably means that the direction of the current is actually away from lead EVR, hence the axis is 30 degrees. Let's say if the deflection would have been this way, then it means that the flow of the current is actually towards lead EVR, towards the positive electrode of the EVR, because we know when the current flows towards the positive electrode, it will show a positive deflection. Then the axis would have been minus 150 degrees, which is definitely abnormal. But here you see that the flow of the current is actually downwards. And how do we get to know? Because the deflection is negative. The deflection is negative in the lead EVR. That means the flow of the current is towards the negative electrode or towards or away from the positive electrode, right? So this is how we see the electrical axis. So the first step that we do is you have to find a lead which has isoelectric deflection. The second thing is you have to move to a lead perpendicular, and then you have to observe the type of deflection in the perpendicular lead and interpret accordingly. What do I mean to say interpret accordingly? That means that if you see a negative deflection, that means the current might be flowing away from that particular lead, hence the angle is going to be 30 degrees, right? The axis is going to be 30 degrees. If it would have been a positive reflection, then the axis would have been minus 150 degrees. So this was pretty much about it. One thing that I would like to talk about here again for your clarification is, whenever I talk about that lead to lead AVR and stuff like that, whenever I say that, that means lead 3 is situated here. That means the positive electrode is at plus 120 degrees. And when I say lead AVR is located here, that means the positive electrode is at minus 150 degrees. So it's always with respect to the positive electrodes. That is why I told you to be aware of the polarity of the electrodes as well, right? And you will see that all these leads are at a distance of 30 degree each, and this is gonna be the positive side and this is gonna be the negative side. Definitely this is a clockwise rotation, hence positive, and this is an anti-clockwise, right? When you go from here to here, it's gonna be anti-clockwise. So if you see, it's 30, 60, 90, 120, right, and so on. Similarly here, it's gonna be minus 30, minus 60, and so on. So the lead, when I talk about lead, when you talk about the direction of the current, just make sure that you know about the polarity of the lead as well, just not only the location. Okay, I hope it's clear.